So in assignment 2, there is a problem about a spin 1 Stern-Gerlach experiment, okay? So if I have, let's just like make sure that you guys understand the discussion. So if I have a Stern-Gerlach magnet and I have a beam of spin 1 particle going through, what will happen when it comes out? So we have an oven here. So oven is producing a mixture of it's in the spin 1 particle in all kinds of states. We don't have any control over that. So what do you expect coming out of the Stern-Gerlach magnet?
Three separate beams.
3 separate beams. Okay. Anyone else wants to chip in? Does people agree with that or disagree with that?
Yes, I agree.
Okay, so we have other people in class. So anyone else wants to, opine?
I'm not super clear yet.
Okay. So Nahi, do you want to explain why you think there would be 3 beams coming out?
So my reason was that since it's spin half to, so we have this discrete spectrum of -1, 0, and 1. And each of those would correspond to a particular beam, depending on how they're being drifted with the magnetic field.
So you're saying that in the SZ basis, this beam is going to have particles whose spin is plus h bar, 0 h bar, and minus h bar, right?
Yes, sir.
So 0 h bar is 0, of course. Josh, what do you think?
Yeah, I had the same idea,
Okay.
like 3 separate
So
states.
Rahul, do you follow what they're trying to say?
Yeah, I get it now. I get it.
Oh, so you guys are right. There will be 3 beams coming out. And that's because the magnet is, the magnetic field is inhomogeneous, they will couple with these 3 spins differently, putting different amounts of force, and therefore they will split into 3 beams. Okay, so anyway, I want you to keep in mind this, and then follow. Okay, one more follow-up questions. What do you think the intensity of these beams would be? Relative intensities. What's your gut feeling?
I want to say the middle one has the highest, but I feel like that's wrong. I don't know, really.
Okay, so you said middle one is highest. Anyone else? Do you have a reason for that, or just it's just your instinct, intuition?
I say it's more of a gut feeling, but that's all.
Anyone else wants to offer their opinion?
I have a similar gut feeling that they would all be equally intense, but what Sujosh said also makes some sense, like if you're talking about gut feelings.
Okay, well, yeah, gut feelings depends on the bacteria in your gut, right? Okay, okay, good. So Sujosh and Rahul have different gut feelings, which is good because that makes it interesting. Anyone else? Okay, so what we don't know is that how precisely this beam is made out of. But statistically, because this beam consists of many, many particles, if we were to look at the beam, so suppose we were, I don't know, like we somehow had a way of telling. Suppose we had a spy in the oven who was telling us. Therefore, statistically, we would expect 1/3 of the particles to be, spinning up, 1/3 of the particle to be spinning down, and 1/3 of the particles spinning neither up nor down, right? So I think Rahul's expectation would be justified that they would all be equal intensity. Okay, that's my gut feeling. It doesn't have to be right. Okay, so the Stern-Gerlach experiment is extremely, extremely important. Not just this, when you have more than one magnet, when you have 3 magnets, and what happens when you block, say, 1 or 2 of these things. So in the assignment problem, you will be blocking 2 of these, okay, and letting the upper beam go through to another 2 more magnets, right? So, and how you express, the eigenstate of the SZ operator in terms of SX operator and SY operator, those things also play a very, very important role. All right. Okay, let's any more questions before we move on?